Hello everyone, welcome to another problem-solving session of organic chemistry, and today we will solve 28 questions for the carbonyl group compound. But before starting our questions, I want you to remind the priority order of functional group. And recently I submitted an Instagram post about this, and here you see the post, the priority order of functional groups from bottom to top, the order increases. And at the bottom, we have the alkanes. And as you see, there is a simple structure of these functional groups, then the suffix names, prefix names, and some examples. And we did hydrocarbons, alkanes, alkynes, and alkenes. We did amines, phenols, and continue. The phenols, alcohols, and after this we have the carbonyl group compounds, and the one has the least priority is the ketones, then aldehyde, this is the pattern CHO, carbonyl group between two R's, and nitrile. And by the way, the suffix of aldehyde common is the Al. So as we did in the bonds containing single bonded hetero atom, we will give their alkane names and derive them to the functional group, derive them to the superior functional group. And aldehyde Al and the ketone ONE, and the prefix names oxo for both, and instead of oxo we can use formyl. And for the nitrile, carbonitrile or cyano as the prefix. And here the amide, then acid halides, esters, carboxylic anhydride, sulfonic acid, and carboxylic acid. And today we have questions about carboxylic acids, esters, and amide. And as you see, the carboxylic acid has the highest priority order. This means if we have an carboxylic acid functional group COOH in a given compound, it will be the suffix. Thus, the carbon chain carrying the carboxylic acid functional group will be the parent chain. And also don't forget we have the subordinate groups, which are always named as an substituent. And for the suffix name here you see the sulfide. They are the common names actually. The prefix are alkoxy, alkyl trio, and the other ones. So after this little remindment to you, let's start the questions. Yes, let's start with the question 1. The UPAC name of the compound. So remember our formula for the UPAC naming. Prefix plus parent chain plus suffix. So the suffix tells us the superior functional group. The parent chain tells us the longest carbon chain having the suffix. And for the rest, we use prefixes. What are the substituents or other functional groups? Their locant and the number. And also don't forget, if there are 2 or 3 suffixes, we have to use determinant for the numbers, such as in carboxylic acid, if there are 2, D-enoic acid or anoic acid, depends on the carbon chain, or alcohol, diol, triol, etc. And for the prefix, also it's same. And if there is an cyclic structure, also we have to use this cycloname to refer the parent chain is a cyclic structure. And also, if there is a suffix, we have to give the position of the suffix, the carbon numbers. And remember this information from the previous ones. Let's start the question 1. UPAC name of the compound. And as you see here, we have a carbonyl group. And so thus this carbonyl group forms 2 sigma bonds with another carbon backbone. So we have the pattern R bonded to the carbonyl group and the second R. So this is a ketone. This is ketone, my friends. So the suffix must be O and E. And let's check the options. As you see, there is all options include the O and E suffix. We cannot eliminate any of them. So the UPAC name, according to the UPAC nomenclature rules, the functional group or the carbon atom having the functional group must be the lowest carbon number. So we have start to the right side. 1, 2. This is 3, 4, 5, 6, which is an hexane ring, not ring, sorry, hexane chain, hexane. And my dear friends, drop the E here, drop E and put ONE. This is hexanone. So eliminate pentanone and pentanone. But as you see, we have two options, 2-hexanone and 5-hexanone. The true one is the 2-hexanone. So the on is the suffix, 2 is the position of our suffix, and hexane refers the longest parent chain. And as you see, there is no any other substituent or functional group in the molecule. Thus, our answer is 2-hexanone. This is the answer, my dear friends, 2-hexanone. Yes, this is the UPAC name, but we can also put a common name for the given ketone compound because it's a simple ketone. And the common name is done according to the given the alkyl names of the both R's, which is methyl. And as you see, this is methyl, 1, 2, 3, 4. This is butyl, so the name will be butyl methyl ketone. This is the common naming, my dear friends. Continue to the question 2. Reduction of aldehydes yields what? The reduction of aldehydes, my dear friends, will lead to primary alcohol. Primary alcohol. This is the answer, not the secondary alcohols, as the ketones. The reduction of ketones can yield to secondary alcohols, not the ketones. And the carboxylic acid, oxidation of aldehydes yields carboxylic acid, not the reduction. The answer is primary alcohols. Yes, a given compound here, the common name of the compound. What is the common name? And as you see, this is a ketone. 1 R here, which is the methyl, and this is propyl, so the name will be methyl propyl ketone. This is the answer, my dear friends. Or no, I hear your voice. No, I said methyl propyl. The meth comes from propyl. This is the answer. What is the UPAC name? I assume question is asking for the UPAC name. UPAC then will be 1, 2, 3, 4, 5 pentanone, 2-pentanone. So this is the UPAC name, 2-pentanone. Continuing question 4, compound by functional group. Which functional group is carried by the compound? And as you see, we have a carbonyl group. Thus, we have to think the carbonyl group compounds. And if there is a hydrogen attached to carbonyl carbon, which makes it the CHO, and this is our R, this is an aldehyde. This is an aldehyde. To be a carboxylic acid, it must carry the carbonyl, carbon, carbonyl oxygen, and then OH group or hydroxyl group attached to carbonyl carbon. To be a ketone, R bonded to the carbonyl group and the second R, or the carbonyl group locates between 2 R's, and to be a ester, R carbonyl group attached to an oxygen and the second R. This is the ester. Yes, continuing question 5. Compound by functional group. Another question asking to find the functional group. And I guess you can rapidly say the ketone. This is R and R. So there are 2 identical groups, the methyl. So dimethyl ketone. Its common name is dimethyl. The common name is dimethyl ketone. It's a simple ketone. And what about this UPAC name? It is 2-propanone. It's 2-propanone. This is the UPAC name. Continuing question 6. Functional groups highlighted using arrows. They are what? And as you see here, an oxygen, but here the oxygen attached to carbon with the double bond. This is carbonyl, and there are 2 R's, which makes it a ketone. And for the other group here, this one is a ether. And again, an R here and an R here. So between 2 R's, if we have an oxygen, it's ether. If we have a carbonyl group, it's a ketone. This is ketone. This is ether. Be careful, my dear friends. So where is the correct option? Ether and ketone here. This is the answer, my dear friends. Okay, my dear friends, it's time for the question 7. Which statement about the butanone is true? So carefully read the questions. What's asking to you? True, false, incorrect, correct, not true, wrong, all are different. So about the butanone. Before checking the options, let's draw the formula of butanone. And as you see, there is something missing in the butanol, the position of the ketone group. But according to the nature of ketone groups, let me slide up here, look at the ketone. The ketone group is always between two R's. No possibility to be at the one end of the chain. So it's a ketone, there is only one possibility, to be here, or my dear friends, to be here. But as you see, it doesn't matter, the position, to be here or here. It is always 2-butanol. It is always 2-butanol. No other possibility. Delete this one. Okay, so this is the 2-butanol. I omit to draw the hydrogens. You can fill it the rest for hydrogen to fill the to fulfill the number of double bonds of a carbon atom to 4 bonds. Okay, it has a cyclic structure. No, this is not true, my dear friend. It's an aliphatic. How can we understand it's a cyclic? There would be a cyclo name, such as cyclobutanol, for example, but there is no cyclo suffix. This is incorrect. Carbonyl group is the polar group. Yes, this is true. It can be prepared by the reduction of the 1-butanol. Actually not. The ketone can be prepared by the oxidation of secondary alcohols, not the primary. This is a primary alcohol. It's an aldehyde? No, it's a ketone. So we know the true option, this one. C, my dear friends. Carbonyl group is the polar group. Yes. Continue on the question 8. Question 8. Which suffix is used in the UPAC nomenclature of organic compounds containing aldehyde? It's very easy. Al. Let's give the answer. We have the answer A. What about the rest? The on is for ketones, all is for alcohols, and 8 is for ester. Ester, alcohol, and this is ketone. Question 9. Blah, 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 commonly known as formaldehyde, and is used as a preservative or fixer for formaldehyde. So we should look for an aldehyde. So ethanol is an alcohol, propanol is aldehyde, ethanol is an aldehyde, methanol aldehyde. This is a ketone. So we have 3 possibilities. And the formaldehyde means methanol. The answer is methanol. So this is a common name, methanol. 10. The simplest ketone, which means ketone has the possible lowest number of carbon chain. And remember the ketone formula, the R, carbonyl, the second R. So there's only one possibility. The R's are methyl groups, which makes it a 2-propanone, my dear friends. So the answer is option. There's no possibility to be 1-propanone. No possibility. Question 11. Difference between an aldehyde and a ketone. What is the difference? Number of oxygen atoms? No. Position of carbon atoms? Maybe. Number of bonding carbon atoms? The number of bonding carbon atoms? No. Position or arrangement of the carbonyl? Yes. Definitely true. The position of carbon atoms? No. It's controversial, my dear friends, but this statement does not make a clear definition, because the real thing is the position of the carbonyl group. Because in aldehydes, the carbonyl group is always at the first position as nature. Remember, C, carbonyl group, and then hydrogen, which makes it a first carbon, if there is no another superior group. Positional arrangement of carbonyl group, this is the important. For the ketones, we have the carbonyl group between 2 identical or different R groups. So this is why the position of carbonyl group, not the position of carbon. This is more general. It's not a concise statement. So the answer is D, my dear friends. Question 12. UPAC name again is asking to us, and we have this suffix. It's very easy now. I think the aldehyde, the Al, thus eliminate the option D. As a nature of aldehydes, the carbonyl carbon is always the first, so continue second, third, and fourth. What about if we follow this way? Again, it's fourth, because these are identical groups and attached to the same carbon. It doesn't matter. Let us see if there is one more carbon here. We follow it that way, because we have to find the longest carbon chain, having the superior functional group. So this is the substituent. We have a methyl substituent attached to a carbon chain having an aldehyde. And as you see, the carbon chain carry 4 carbon, which makes this a butanol. Butanol. Eliminate the propanol. We have 2 remaining options. So, and now it's still very easy. It's still very easy, my dear friends, because Al group is always at the first. So eliminate this one. This is not true. It is 1 butanol. And always we can omit the 1 butanol because it is always 1 butanol if it is the superior group. And the methyl group is at the 3rd carbon, as you see here. So the answer is, my friends, B. 3-methyl 1-butanol. Or we can omit to put the 1, which makes the name 3-methyl butanol. That's okay. 3-methyl butanol. Question 13. Which of the statements about aldehydes and ketones are correct? Correct. So we have to look for the correct statement. Let's do it. So the ketones are insoluble in water. This is not true, or we cannot make a general statement about solubility or insolubility in water because the simplest one can solubility the polar group. This is incorrect. Ketones have lower boiling points compared to alcohols of similar size. This is true because alcohol can form hydrogen bondings, which make higher boiling point. And also, what means the compared, having the similar size, which means they have a same number of carbon atoms in the backbone. Thus, the difference is only the functional group. Intermolecular interactions are weaker than alcohols. This is also true. This is about, again, the hydrogen bonding. Aldehydes have low boiling points to hydrocarbons of similar size. No, this is incorrect. Higher boiling points. Aldehydes have higher boiling points. And aldehydes and ketones show dipole-dipole interactions. They have the carbonyl group. This is also true, my dear friend. The 3 statements, C, E, and B, are true. Question 14. What functional group or groups is there on the molecule? So check all appropriate options. So I want you to define functional groups. Look at the carbon backbone. Here we have a carbon, and nitrogen. So we have 2 important functional groups having nitrogen, amines and amide. And as you see, this is an NH2 attached to a carbon with a single bond, which makes it an amine. We have amine. And here we have the famous carbonyl group having an hydroxyl, makes it carboxyl, carboxylic acid. And we have the answer, carboxylic acid and amine functional group, which its prefix name is amino, B and C. By the way, look at here, this is the R group, a variable group. This is the general structure of the amino acid. Question 15. Classify the compound according to the functional group present. Look at here, we have a carbonyl having an 1 oxygen and an R, and here the second R, which is R, my dear friends, slash the carbonyl, the oxygen, and the second R. This is ester, an ester group. This is C. Question 16 behaves as an organic acid, carboxylic acid, or carboxylic, COH, and double anti-oxygen, carboxylic acid. That's amino groups, for example, amino acids, they are carboxylic acid. They are organic acid. Fatty acid, they are organic acids. They have carboxyl group. And question 17. Condensation of a carboxylic acid and an alcohol yields what? Which means, let's draw the general pattern. So we have a carboxylic acid plus an alcohol. The condensation of this reaction gives what? At the end of this reaction, which is an esterification. It's a Fischer's esterification reaction. The removal of hydroxyl group and hydrogen as a water molecule. Thus binding this oxygen to here will yield what? Will yield, as you see, a 1 mole of water molecule and that ester molecule, which makes the answer E, an ester and water. This is Fischer's esterification. And these are the general reactions of acids and alcohols. Condensation reactions of acids and alcohols. Question 18. Carboxylic acids have boiling points than esters having a comparable size, and boiling points than alcohols having a comparable size. Higher. This is the answer, my dear friend. Carboxylic acids have higher boiling points than esters having a comparable size, and boiling points than alcohols having a comparable size. Question 19. Which of the following acids are most soluble? Get the options, but they all carry one carboxylic acid, only one COOH. So there's no difference in terms of the functional groups. So we should focus on the carbon chain. Nonanoic acid, 9 carbon. Octanoic, 8. Ethanoic, 2. And hexanoic, 6. So the higher the carbon chain, decrease the solubility in water. So most soluble one is ethanoic acid. Ethanoic acid. Question 20. UPAC name of the compound. And look at here. We have a carboxyl group and an alcohol group. So which is the superior one? The carboxylic. Thus, the carbon chain having a carboxylic group is the parent chain. This is the first carbon, 2, 3, and 4. So this will be a prefix at the third group. And the prefix name of the alcohols is hydroxy. And we have an oic acid. 4 carbon means butanoic acid. Not necessary to say 1 butanoic, we can omit. And the hydroxy attached to 3 carbon, third carbon, 3 hydroxy butanoic acid. 3 hydroxy butanoic acid. So this is the answer, my dear friend. A good question comparing the superiority of functional groups. So if there are 2 or 3 or more different functional groups, look at the superior ones. The carbon having the superior must be the part of a parent chain. And so continue on question 21. Which compound has the highest boiling point? And look at the example. The butanol, butanoic acid, the ethyl ether, and the butane. What is the common feature of these compounds? Because we should find the common feature and also then a different feature. So there must be something comparable. And the common feature here is all given compounds carry 4 carbon atoms as a backbone, but they differ in the functional group. So this is an alcohol, ether, the alkane, and the carboxylic acid. So we have to order them according to the functional group they carry. And the answer is very easy. The one has the highest polarity and also the ability to form hydrogen bonding is the highest boiling point, which is, tell me, yes, correct. The butanoic acid is the answer, my dear friends. Then butanol, then ether, and then butane. For the butane, -1 degree Celsius, the boiling point. The ethyl ether, plus 34.6 degrees Celsius. For the butanol, 100 degrees Celsius. And the butanoic acid, 163.5 degrees Celsius. Even they carry the same number of carbon atoms and the backbone, due to the functional groups they have, the boiling points are very different. Yes, question 20. From the lowest to the highest, what is the correct boiling point of the carboxylic acid? So all given compounds are carboxylic acid. This means we will check the number of carbon atoms in the backbone, because the higher the carbon number increases the boiling point. So methanoic acid, ethanoic, butanoic, and propionic acid. So this is 1 carbon, 2, 4, 3. This is incorrect. 2 methanoic, 1 incorrect, methanoic, 1 ethanoic, 2, propionic, 3, and butanoic acid 4, 1, 3, 2. This is also incorrect. So we have the option. This is the true option, my dear friends. Yes, 23. Question 23. Again, a UPAC naming, and it's very easy. I think we have the carboxylic acid, 1, 2, 3, 4, 5, which makes a pentanoic acid. So eliminate. And at the 4th carbon, we have a 2-methyl group, where exists the 4,4-dimethyl butanoic acid. 4,4-dimethyl pentanoic acid. And as you see, it is getting easier. UPAC name of the compound again. UPAC name. So we have a 1, 2, 3, 4. Oops, this is an ester. So 8. The suffix 8 or OA. Actually, this is the UPAC name. This is the common name, 8. So we have a carbon chain here, as you see, my dear friends, having one R and R. So the carbon attached to carbonyl carbon is the parent chain. This is for esters. So no matter how many carbon atoms are found in the carbon backbone attached to the oxygen of the ether, it's not the parent chain. The parent chain is always the carbon group or the alkyl group attached to the carbonyl carbon. And there are 4 carbon butanoid. So it is an ethyl butanoid because it is named as an alkyl group. Ethyl butanoid. By the way, this is the correct option, my dear friends, because shortly 8, as you see here, ethyl butyrate, this is the common name. This is common name. The O here creates a big difference, my friends. Question 25, my friends. The UPAC name of the compound. So we have the halogens, as you see, fluoro groups, fluorines, and here the carboxylic acid. 1, 2, 3, 4. Don't forget the carboxyl group here. The carbonyl carbon is the first carbon. So it's a butanoic acid. Eliminate this one, this one. And 2, 3, 4, 3 fluoro. 2, 3, 4, 3 fluoro. This is the answer. Option D. What carboxylic acid in the question 26? Carboxylic acid and alcohol condense to form the given ester. To analyze the group, so this is the second R. This is the alkyl moiety of the alcohol attaching to the carbonyl carbon. So actually this oxygen here comes from the oxygen of alcohol. So 1, 2, 3, 4, 5, 6, 7. This means an heptanol. Heptanol, not the propanol. Eliminate and option A. And here we have the 2 carbon and 3 carbon. 3 carbon, which is a propanolic acid. This is the answer. Option A. Continue on the 27. Identify the functional groups of the given molecule and name it following systematic rules, which is the UPAC rule. The functional groups are very easy. As you see, we have a carboxylic acid, which will be an oic acid. But there is an alkane. This is ene suffix. Alkene suffix. Alkene, not alkyne, sorry, alkene. So this is the superior group. 1, 2, 3, 4, 5, 6, 7, 8, and here the 9, and 10, 11, 12, 13, 14, 15, 16, 17, 18. So what is the UPAC multiplier for 18? Octadecene. Octadecene, because it's an alkene, not an alkane. So drop E here, the oic acid, which will be deconoic acid. Octadecanoic acid. We have an oic acid as the first. It's always same and not different. It's always at the first position. Thus, it's not necessary to put the mono or the one suffix, it's always. But we have to mention the position of double bond. It's the 9. 9 octadecanoic acid. And it is in the cis formation, as you see. Cis formation, because here we have hydrogens. So the carbon backbones are at the same side. So the double bond has a cis formation. Cis 9 octadecanoic acid. This is the UPAC name. And its common name is oleic acid. Oleic acid. And it's an omega-9 class of fatty acid. The carbonyl carbon is the one. The second carbon is here alpha carbon. The third carbon is beta. And at the end, it is called omega carbon. And if we start from the omega and number the carbon atoms, then we will see the first double bond at the 9th position from the omega. This is why it's an omega-9 fatty acid. This 9 octadecanoic acid, oleic acid. Yes, question 28. Again, the UPAC name of the compound. Yes, again, we have a carboxylic acid. Oh my God, we have an alcoholic group and an amino group, my dear. So to name the molecule suffix, we know it's an oic acid. Because carboxylic acid has the highest probability than the alcohol and the amino group. The amino and the alcohol will be prefixes. So let's number the carbon backbone. 1, 2, 3. So it is a propionic acid. Propionic acid, my dear friend. But the propionic acid having hydroxyl group at the third carbon and amino group at the second carbon. So 2 amino, 3 hydroxy propionic acid is the UPAC name of the given compound, my dear friends. This is the UPAC name. What is the common name? Common name of this carboxylic acid is, my dear friends, it's serine. It's an amino acid. It's a protein amino acid having an alcoholic group. And there are 3 amino acids having alcoholic group. The one is serine. The other ones are threonine and the tyrosine. But actually tyrosine carry phenolic group. Yes, question 28 is the last one. So, we've finished, my dear friends. This is the end. And don't forget to subscribe to the channel, like the video, and click on the ring bell to get the notification. Stay safe and see you on the next video. Ciao.